Hi, hello everyone. Welcome back to our channel Samartha Official. In this video, you will learn how to model a plate with hole. Here you will model a 3D model. So here the thickness of the plate with hole is very less compared to length and width. So you will consider the 3D model and you will analyze this by using ANSYS workbench. So the module used here is ANSYS static structural analysis, and you need to compute maximum deflection and stress. The material is structural steel and the thickness, as we discussed, it is 10 mm. Okay. Open ANSYS workbench. Minimize analysis systems. Maximize component systems. Go to geometry. Select this. Drag this and leave here at create standalone system. So now geometry is in question mark. You can edit this name, plate with hole. Press enter. Select this geometry. As we are creating 3D geometry, you ensure solid bodies is in tick mark. Select this geometry, right click, new design modular geometry. So design modular workspace is open. Select any of the planes. I'll select XY plane, right click, look at. So go to units, click on millimeters. As the dimensions of the problem what we have shown previously are in millimeters, so you select it as millimeters. Now go to sketching, select a rectangle, click anywhere else here and click here, drag it and click here. So now go to dimensions. So make sure general is selected. Select this vertical line, drag it and click it here. Select this horizontal line, drag it and click it here. So now you need to give the dimensions. So V1, the value of V1 is 400. Press enter. The value of H2 is 1000. Press enter. So right click, zoom to fit, or press F7. Okay. Now click on constraints. Click on this down arrow. Select symmetry. Select this axis line. Select this bottom line and select this top line. Right click, zoom to fit. So you can see the symmetry is created here. So again, press escape now. Click on symmetry. Select this vertical axis, means y-axis. Select this vertical line and select this vertical line. Right click, zoom to fit. So you can see the symmetry is created for the rectangle as the given body is symmetric about both the axes. Now click on draw. Select the circle. Ensure the center of the circle and center of rectangle are coincident. Click here, drag it and click somewhere like with some other dimensions. So now you need to give the dimensions. Click on dimensions, click on general, select this circle, click here. So you need to give value to this D3. D3 value is 200. Press enter. Okay. So now you need to extrude this. Click on extrude. So you need to click on apply. Before clicking on apply, you need to give the depth of this. So I'll select, like I'll give this value as 10. Press enter. As the thickness of this is 10, I'll give this value as 10. So you can see this thunderbolt symbol here near extrude. So it is not generated. Now click on generate. So you can see the solid body is created. Right click, isometric view, right click, zoom to fit. Okay. Now go to file, click on close design modeler. So now minimize this component system, maximize this analysis system. Select the static structural, drag this to A2 cell, which is nothing but geometry. So you will get this share A2 red color box. Leave it here. So there was a link formed from geometry to this static structural analysis. Okay. So you can rename this as plate with hole analysis. Press enter. So select this model, right click, edit. So the geometry what you have created has been updated here. So you can see in the materials, the material it has taken as structural steel. This is the default material. Now you can select the mesh, right click, update or generate mesh. So this is system generated mesh. So I'll create a mesh, click on generate mesh. So this is program control mesh that has been generated. Okay, you can see a green tick mark at the mesh. So now there is a question mark at the static structural. Select the static structural. So you need to give loads and boundary conditions here. Right click, insert, fix it support. So now just click on center scroll button and move it. For zooming in, just move the scroll button. So now I need to select this surface. Before selecting this surface, ensure the face option is selected here and select this surface and click on apply. A fixed support is applied on the surface. So now you need to give a force on the surface. So for this, you select static structural, right click, insert, force. Okay. So now select this surface, click on apply. So in this define by option, you just change it to components. So now I need to apply a force along x direction, positive x direction. So the force is 100 kilonewtons. So I'll give the units here is Newton. So I'll give 100 into 10 cube, means 100 and 3 zeros. Press enter. Okay, force, if force is applied, right click, view, front, right click, zoom to fit. So you can see a force is applied here on this face and a fixed support is applied here. So now you need to solve the solution. Select the solution, right click, solve. So you can see green tick marks here means the solution is solved. In order to view the results, you need to give the results what you need. So for this, you need to go for post processing, select the solution, right click, insert, stress, equivalent von Mises stress. Again, select this solution, right click, insert, deformation, total deformation. So you can see a thunderbolt symbol here means the solution is solved, but to view the results it need to be evaluated. For this, you select this, right click, evaluate all results. Okay, so you can see green tick marks here means the results are evaluated. So click on this equivalent stress, you can see a maximum stress of 95.618 and click on total deformation. You can see maximum deformation of 0.16523. The units are in mm, and for this equivalent stress units are in megapascal. Okay, you can look for animation, click on play. So you can see how the stress distribution is happening. You can click on total deformation. You can click on play animation. So you can see the maximum deformation and minimum deformation. Red color indicates the maximum deformation and blue color indicates this minimum deformation. And in between values, there is a change in color. Thank you.